Yeah, welcome to today's class. This evening we shall be looking at set theory, and first and foremost, as you can see on the screen, we have the topic there already, set theory, and we have the first example. But before going to first example, let's quickly do a recap of what you will have learned in the past on this topic, and probably talk about the most important aspect of this topic. The most important aspect of this topic is you need to be familiar with the symbols, the set notations, and their functions. The functions they perform, and all other stuffs like that. But if you've not been able to get yourself familiar with this, it's not too late. This is the part of this what you will have done in probably your year 10, that is SS1 class. But if probably you cannot remember all this, I would recommend that you pick up a new general mathematics SS1 and check a topic, set theory 1. You're going to see all these symbols, all these set notations there, and the functions they perform. Because in today's class we are not going to be looking at all those ones, because they are what you will have done right in your year 10. And probably if you are in year 10, in most of the curriculum presently, you will have done it, or probably you are doing it right away. So I want to believe nothing will be strange in the topic tonight. So let's just go straight to the examples. Tonight we are going to be solving some past examination questions on set, and the questions picked as our examples tonight will cut across almost all what you need to know in set theory. But after the class, if there's any other thing that you think we've not touched in this topic, just feel free to drop it as a question in the comment section, and it will be attended to. So let's go straight to example number 1. In our example number 1, which is past 5 question of 1999, question 2, that is theory question number 2. The question says, if U is the set of number 1, 2, 3 up to 10, you can see it in the bracket there. U is a set of number 1, 2, 3 up to 10. Whenever you see this dot dot dot, that is, it's showing the continuation of the number from 3 to 10. And A, B, and C are subsets of U. I want to believe you know what subset represents. When we say a set is a subset of another one, that is, that set, all the elements of that set can be found in the other one. That is what subset simply means. That is, if A is a subset of U, it means all elements of A can be found in set U. That is what this one is telling us. Okay, according to the question, A, B, and C are subsets of this U, and such that A is equal to multiples of 5, B equal to multiples of 4, and C equal to multiples of 3. What is the implication of this? They ask us to list the element of A, B, and C, and also use this element to solve some other problems. What is the implication of this? U is a set of numbers from 1 to 10, and A is a subset of U, but A is a multiple of 5. That is, what this one is telling us is that A is multiples of 5 between 1 and 10. Multiples of 5 that falls within the range of number 1 to 10. That is what this one is telling us. That's why we have the word A is a subset of U. That is not multiples of 5 outside 1 to 10, or not multiples of 5 outside the set U. Also, similarly, B is a multiples of 4 between number 1 to 10, and C is multiples of 3. So let's see how we solve this by listing out the element of A, B, and C. That is the first part of our question. Okay, let's start with the solution to A. Okay. Now for A is a multiple of 5 and it's a subset of U. Therefore, you can say our A, Roman figure 1, A will be equal to multiple of 5 between 1 and 10 is 5 and 10. I want to believe we all know what multiple of 5 simply represent. That is all the numbers that 5 will be able to divide. Those are the multiples of 5. And for Roman figure 2, we have B, which is multiples of 4. So multiple of 4 between 1 and 10 are, we have 4, 8. These are the multiples of 4 between 1 and 10. We have 4 and 8. There's no other number that 4 can divide without remainder. And C is multiple of 3. So Roman figure 3, C equal to multiple of 3. These are 3, 6, 9. Those are the multiples of 3 that are between number 1 to 10. Okay, let's see the B part of our question. The B part of our question says, what do we have in B part of our question? In B part of our question, we have to find A intersection B. Roman figure 2 there says A intersection C, and Roman figure 3 says B union C. Okay, now let's start with the first one, A intersection B. For A intersection B, A intersection B simply means the element of A that you can find in B, that is A intersection B. The element of A that you can find in B, sorry, I think something is not right with the question. Okay. Yes, sorry. Let me correct something in the question. Here we have 20, and here we have 19. Sorry for that. Sorry for that. We'll go through A again. Use a set of numbers between 1 to 20, not 1 to 10, so that we'll have a reasonable values. Let's just add to the value, and if that is the case, it means our A here, which is multiples of 5, we still have some other values like you still have like 15 and 20 itself is a multiples of 5, and in the case of this multiples of 4, I'm going to have more elements. For multiples of 4, I'm going to have 12, 16, 20. All of them, they are multiples of 4. And for multiples of 3, now for multiples of 3, I'm going to have some other numbers as well. I'm going to have a 12, I'm going to have 15, I'm going to have 18, and that should be all for multiples of 3. Sorry for that. There's a typographical error in the question in the first place, so that is what we quickly correct. U is a set of numbers from 1 to 20, not 1 to 10. That is what I try to correct here. U is set of numbers from 1 to 20, not 1 to 10. And with that, we have more elements for each of these sets. Okay, let's move on to the next part of the question. So A intersection B, what is the meaning of intersection when we talk about set? Intersection simply means what two sets are having in common without repetition. That is the element that A and B are having in common. That is A intersection B. And if you check A and B, what we have, what they have in common should be, what they have in common, if you look through A and B, in A we have 20, and we also have 20 in B, and that's the only number they have in common. So A intersection B will be equal to 20. And for Roman figure 2, we have A intersection C. Let me create a little space there so that you see clearly. A intersection C. Similarly, A intersection C simply means what A and C are having in common without repetition. That is A intersection C. And let's quickly check. These are the elements of A, and these are the elements of C. So what do they have in common? We can see that in A we have 15, and in C we also have 15. Aside from that 15, no other letter or no other number is common to both of them. So we can easily go back to this and say A intersection C is equal to 15. Now for the third question, we have in the third question we have B union C. We have B union C, and if you look at it, union simply means what they both have without all the element of all the element of B and C with no repetition. That is what union simply means. All the element of B and C without repetition. We're going to write out all the element of B and C. Okay, so we can quickly do that. Now all the elements of B and C are 3, 4, 6, 8, 9, 12, and we continue like that. We have 15, we have 16, we have 18, and we have 20. Those are the elements of the two sets B and C without repetition. So the element of B and C without repetition. So union simply means all the elements of B and C without repetition, all the elements of the two sets without repetition. That is what union represents. Okay, now let's go to part C of the question. In part C, A intersection B union A intersection C equal to A intersection B union C. Let's check that out. Okay, A intersection B is 20. Okay, let's see part of the question. A intersection B and A intersection B union A intersection C. We've done that already, so let's just bring the value down. Let's check again. This is our A intersection B, which is equal to 20. this is our A intersection C, which is equal to 15. So what's the union between the two of them? That is all their elements without repetition. Okay, let's go there, which means we are going to have this to be equal to 15, 20 without 15, 20. Those are the two elements that we have in A intersection B and A intersection C. So their union is the two elements. Okay, let's check for the other side of the equation where we have A intersection B union C. So what would this one be? And this one simply means the element of A, what element of A is having in common with all the element of B union C. Let's go back to B union C and A. The element of A are right here, 5, 10, 15, and 20. And what about B union C? They are right here. We have them as 3, 4, 6, 8, 9, 12, 15, 16, 18, and 20. So what is now their intersection? What do they have in common? Okay, let's see what they have in common. A intersection B union C, what they have in common, and that is also equal to 15 and 20. If you check very well, that is equal to 15 and 20. Therefore, we can say therefore A intersection B union A intersection C equal to A intersection B union C. So we've been able to establish that. Okay, let's quickly rush through what we've done from beginning. We have a question that says we have set U, which is set of number 1 to 20. A, B, and C are subset of U, that is they are part of U. So which means U is serving the purpose of universal set for them there. So A is a multiple of 5, that is the number that can be distributed by 5 without remainder between 1 and 20. B is multiples of 4, that is a number between 1 and 20 that is divisible by 4 without remainder. Similarly, 3 is a multiple of 3. We are asked to list the element of A, B, and C, and we're able to do that in our A part of the equation. In B part of the equation, we are asked to list out the element of A intersection B. Remember, intersection is what two sets are having, 2 or 3 sets are having, 2 or more sets are having in common without remainder. When we have A intersection B, that is what A and B are having in common. What A and B are having in common, that's the only set that is intersection. Similar to A intersection C, what A and C are having in common, and that number is just 15. Now B union C simply means all the elements of B and C without repeating any of the elements, all the elements of B and C, and we're able to write that out. And the third part has also show that A intersection B union A intersection C equal to A intersection B union C, and we've been able to establish that, and they are equal to each other. Okay, let's go to the next example. In our second example, we have set A, which is 2, 4, 6, 8. The element of set A 2, 4, 6, 8. The element of set B 2, 3, 7, 9, and the element of set C is equal to x, such that 3 less than x less than 9. 3 less than x less than 9. Okay, and according to the question, all these set A, B, and C, they are subsets of universal sets 2, 3, 4, 5, 6, 7, 8, 9. That is A, B, and C. They can be found in universal set which has elements of 2, 3, 4, 5, 6, 7, 8, 9. So the question here is we have to find A intersection B intersection C. That is first question there, that is part A. And part B asks us to find A union B intersection B union C. Let's quickly bring that out. But before we proceed to this A part, I think first thing to do is to have the element of C written out, because C is given in form of equation that we need to bring out the element. Okay, now we can say our C equal to, pay attention to this, C equal to x such that 3 less than x less than 9. That is the set x will start from number 4 and stop at number 8, because 3 is less than x and x is less than 9. And set C must be a subset of universal set, which is 2, 3, 4, 5, 6, 7, 8, 9. So in order to do that, we can say our set C equal to 4, 5, 6, and 8. That is our set C. Sorry, 7 is there, because 7 is in universal set. 7 and 8. That's our set C. Our set C is 4, 5, 6, 7, and 8. Because according to this statement here, 3 is less than x and less than 9. Definitely the set we are looking for, the element we are looking for, 3 is not part of it and 9 is not even part of it. Okay, we can now proceed and solve for and find the value of what A represents. Okay, our A is element of A intersection B intersection C, and I will advise that we first look for B intersection C. What will be the value of element of B intersection C? What will that give us? B intersection C is the first thing that we need to look for, and B intersection C will be the element that B and C have in common. Can we go back and check B and C? C is 4, 5, 6, 7, 8, and B is 2, 3, 7, 9. So the element they have in common is just this number here and this number. So 7 is just the element they have in common, and we can easily put that one here. And now A intersection B intersection C will now be equal to, that is all the element of A now intersection the element of this. Okay, now let's check what A has for us. A is a set of 2, 4, 6, 8. So what does this have in common with B intersection C? Okay, let's just go there. Now A and C, they have nothing in common, no element. They don't have the same elements. They are not having anything in common. So it means A intersection B intersection C is an empty set. And for an empty set, the notation is either having an empty bracket like this, or you can just have a symbol file. This represents empty sets. And for the B part of our question, we have okay, let me move it down. We have to find A union B intersection B union C. That is what that one represents. A union B intersection B union C. And let's quickly look at this. Okay. We have A union B intersection B union C. B union C. Okay, let's quickly find out what is A union B. A union B a set of 2, 3, 4, 6, 7, 8, 9. And this one, you're finding intersection of this and B union C. So what is set of B union C? The set of B union C are the element of B union C rather are 2, 3, 4, 5, 6, 7, 8, and 9. So what is now the union between these two sets? You can see the number they have. Okay, what is now the intersection between the two of them? Those are the number they have in common. They have 2, 3, 4, 6, 7, 8, 9 in common. 2, 3, 4, 6, 7, 8, 9. The only number they don't have in common is number 5. That will not be there. Okay, and we are going to have our final answer to be 2, 3, 4, 6, 7, 8, 9. Okay, and that answers our question. With that, we end our example 2. Okay, let's quickly go through what we've done so far. We have set A with element 2, 4, 6, 8, set B with element 2, 3, 7, 9, and set C with element 4, 5, 6, 7, 8. And we're asked to find A intersection B intersection C. And that gives us empty set because they don't have anything in common. And also we're asked to find A union B intersection B union C. And that gives us 2, 3, 4, 6, 7, 8, 9. Okay, let's consider another example. And in this example, we are going to be using Venn diagram in solving problem. I want to believe you've done this before, but if you've not done it before, just pay attention. Definitely we are going to take it from scratch as well. And if you've done it before, just pay attention so that you can add to your knowledge. But just before I go to this, if you are watching on this channel or you've been using this channel for one thing or the other before and you're yet to subscribe, please kindly do that in order for us to serve you properly. And also, after subscribing, please click the notification button so that you'll be having a notification whenever we're on live programs like this, our live classes like this. And also, if you need one-on-one tutorial with a professional, don't hesitate to reach out to us and that will be handled. And if you have any question or you need my contact, just drop the question at the comment section to request for the contact. Okay, let's go to example number 3. In our example number 3, the question here says 25 students sat for 25 students sat for physics and mathematics examination. 25 of them sat for physics and mathematics examination, and 18 students passed mathematics, 17 passed their physics, and only one student failed both subjects. We have to find the number of students that passed both subjects and the number of students that passed mathematics only. Okay, I would suggest that we use a Venn diagram, though we can use some other approach in solving this problem. But I would suggest that we use Venn diagram so that we can talk about Venn diagram as well. Okay. Now, what is Venn diagram? A Venn diagram is this rectangular diagram that serves as universal set, in which we have all the other sets embedded in it. Let's see. According to this question, two sets are mentioned, which are mathematics and physics. So in our rectangle, we are going to have just two circles because we are dealing with two major sets, which are physics and mathematics. And let's say we represent mathematics with M, mathematics with M, and physics with P. And according to the question, 18 students passed mathematics. That is, this region covered with mathematics covers 18 students, while 17 passed physics. The whole of this equal to 17. But in the question, they ask us to find the student that passed both subjects, and that region is represented with this place, but we don't know it. So let's use letter X to represent those that pass both subjects. And if X is here, and according to the question, we have 18 students passed mathematics. Therefore, this place will be 18 minus X, because this region is part of mathematics. And also 17 passed physics. In this place will be 17 minus X. And according to the question, one student failed both subjects, and that will be here, because what we have within the circle are the number of students that passed. So anything outside the circle simply means that student failed. And according to the question, 25 students sat for physics and mathematics test. That is our universal set. That is, everything that will be in this rectangle must be equal to 25. That is what that statement is telling us. Therefore, we can say our universal set equal to 25. That is, everything within this rectangle must be equal to 25. Okay, let's see how we can find our let's say we can solve the first question, which is the number of students that passed both subjects, which we represented with X in our distance. Okay, now to find that, you're going to say A will be equal to, so we are adding everything together and equate it to 25. Therefore, we have 18 minus X plus X plus 17 minus X plus this one. Everything will be equal to universal set, which is 25. That is, we added this to this, to this, and to this, and we equate everything to 25. Okay, let's see how we go about this. We're going to have 18 plus 17 will definitely give us 35, and 35 minus 1 will be 34. So we have minus X plus X minus X. Definitely we are going to have minus X left, and that will be equal to 25. So collecting the like times, we can say 34 minus 25 will be equal to X. So the number that pass both subjects, which is X, will be equal to 34 minus 25. And 34 minus 25 will definitely give us 18 plus 30 is, oh, sorry for that. Yeah, 18 plus 17 is 35, and that minus 1 will give us 4. Okay, 34 minus 25 will give us 9. To give us 9, and that's the number that passed both subjects. And the B part of this question, the number of students that pass mathematics only. To get the number of students that pass mathematics, this region alone represented students that pass mathematics only, and we found the value of our x to be 9. Therefore, we can say our B part will be equal to number of students that pass only mathematics, and that will be 18 minus 9, and that will be 9 students that pass mathematics only. Let's proceed to the next question, and this one is coming from past WAEC question, that is year 2011 question number 6. We are still going to use Venn diagram, but this time around we are dealing with 3 different sets. So let's see how we go about this. The question says, in a class of 40 students, 18 passed mathematics, 19 passed account, 16 passed economics, 16 passed economics. We have 5 passed mathematics and account only. We have 6 mathematics only. We have 9 account only, and we have 2 candidates that pass account and economics only. So if each student over at least one of the 3 subjects, how many students fail in all subjects? And you have to find the percentage you failed in at least one of the economics and mathematics. Also, we have to calculate the probability that a student at random failed in account. Okay, in order to do this, we are going to draw a Venn diagram again, and we are going to represent the 3 sets in the Venn diagram. Okay, let's say we have a Venn diagram here. This time around we are looking at 3 sets. This time around we are looking at 3 sets. Sorry for that. This is our Venn diagram. We are going to have a 3 sets, and let me redraw that so that we have enough space at the middle. Okay, now, and this set represents a student that did math, economics, and account according to the question. Math, economics, and account. Okay, use M for mathematics again. Let's say mathematics is here, and we have our account here, and let's have our economy here. And according to the question, the total number of students that are for the exam equal to 40. That's our universal set. And based on the information on the question, we have 18 pass mathematics, 19 pass account, 16 pass economics, and 5 pass mathematics and account only. Mathematics and account only, let's start with that. And this column represents mathematics and account only. Sorry, mathematics and account only is here, and that is 5, so we can just put 5 here. I just have 5 here. Let's have our 5 there. And according to the question again, we have 2 students that pass economics and account only. So this is the region for economics and account only. So we have 2 students here, and we have 6 students that pass mathematics only according to the question, and we also have 9 students that pass only account. according to the question. Okay. First question here is, okay, let's first look at let's use a letter to represent the number of students that pass all subjects, and let's say we use X because this place represents students that pass all subjects, and let's use Y to represent students that pass both mathematics and economics, and economics only, let's use letter Z to represent economics only. So, and let's use letter F to represent those that pass or that fail all the subjects. Those that fail all the subject will be outside the circle, and that is what we are looking for. Okay, how do we now go about this? With the information that we have on Venn diagram, we can easily, with this information on the Venn diagram, we can easily find the value of our X. And how do we go about that? According to the question, we have the number that pass account, and let's go back to that and check. The number that pass account, the number of students that pass account equal to 19, and from the Venn diagram, that is represented by what we have here, this, and this, because this entire circle is for account. So we can pick all the elements from that circle, add them together, equate them to number that pass account, and that will be equal to 9. Sorry, the number that pass account according to the question. Nine plus 2 plus 5 plus X, and with this we can get the value of our X, and we are going to have a 19 equal to 9 plus 2 is 11, 11 plus 5 is 16, and we're going to have a 16 plus X. Therefore, we can say our X equal to 19 minus 16, and our X will be equal to 3. So that's the number of the students that pass all the 3 subjects. But mind you, we are looking for number of students that fail all the 3 subjects. So how do you go about this? We can consider mathematics again. Number of students that pass mathematics according to the question. 18 passed mathematics according to the question. We have it here. And if we go back to the Venn diagram, the column for mathematics cover the whole of this, so we can easily bring it out. You can see the number that pass mathematics will be equal to, according to the question, is 18, and which means we can now say 18 equal to all the elements within the circle of mathematics. That will be 6 plus 5 according to the Venn diagram, plus 3, and we use letter Y to represent a portion there, and from there we can just say 18 will be equal to 14y, sorry, 14 plus y. Therefore our column Y will be equal to 18 minus 14. Y will be equal to 4. And according to our Venn diagram, Y represents the region of those that passed mathematics and economics. That is our economics only. Okay, In doing that, according to the question, the number that passed economics, entire economics, is 16. According to the question, we have that one here. Okay, let's just let's take it down, and let's have economics. Number of economics equal to 16. So which means 16 will be equal to 4 plus 3 plus 2 plus Z. And we can easily say Z will be equal to 16 minus 9. And from there, our Z will be equal to 7. And the number that failed, which is equal to F, can be found now by adding every number within the Venn diagram together and equating it to our universal set. So how do we go about that? F is the number that failed, so we can say F plus everything within the Venn diagram, which are 6, 5, according to our Venn diagram, plus 4, plus 3, plus 2, plus 2, plus 7, and equate everything to 40, which is our universal set. With this information, can say our F plus 36 equal to 40. So F will be equal to 40 minus 36. And with this information, we can see the number that failed all the 3 subjects will be 4. The number that failed all the 3 subjects is equal to 4. That is A part of our question. The B part of the question, because of our time, the number that passed either economics or mathematics, let's quickly check. We have to find the percentage of students. Okay, the percentage of students who fail at least one of economics and mathematics. The percentage of students who fail one of economics and mathematics. Okay, to do that, now we need to get the number from the Venn diagram, those that pass economics or mathematics. Number that passed economics or mathematics. Economics or mathematics from the Venn diagram. Number that passed economics or mathematics. If you go back to Venn diagram, we are going to see that number that passed economics or mathematics, they are in this region, so we can easily pick all those numbers and add them together, subtract them from the total number, which is our universal set. Okay, so number that passed economics or mathematics, economics or mathematics will be equal to 6 plus 5 plus 3 plus 4 plus 7 plus 2, and that will be equal to 27. So this is number that passed either economics or mathematics. So number that failed economics or mathematics, number that failed economics or mathematics, will now be equal to universal set minus this 27, and that is equal to 13. So the percentage, taking this to percentage, it means the percentage that failed economics or mathematics will now be, another failed economics or mathematics will now be equal to 13 over 40 multiplied by 100 over 1, and that mathematically will give us 32.5%. And the last part of the question asks us to find the probability, but just because we've not done anything like probability on this channel, we may have to leave that. Because we've not done anything like probability on this channel, we may have to leave that. In our subsequent classes, we are going to consider probability as a topic as well. Now, but just before I close the class, I'd like to play with us again. If you are part of this channel or you are enjoying the advantage of this channel and you are yet to subscribe, please kindly do. And after your subscription, please click on the notification button so that whenever we are having a live section like this, you'll be notified. And if this lesson today has added any value to you, please give us thumbs up and just drop a comment at the comment section. And in case you need you have any question that is bothering your mind in this topic, feel free to drop it at the comment section. The question will be attended to. And if you also need professional touch in both mathematics and physics, you can reach out to us through comment section or probably ask for a number, or you can see my number in the description of this video, and let's discuss. And if you also need comprehensive notes in subjects like physics and mathematics, feel free to reach out to us as well, and we discuss that. And once again tonight, I would like to appreciate everyone for being part of this class, and thank you, and God bless you. Have a nice rest.